Okay, so let me tell you about coupon collecting. Okay, so the classic example that we might hear about today, there's a box of cereal and there are 5 cartoon characters. So box has one of 5 cartoon characters. Okay, and if you collect all 5 cartoon characters, you get a $2 rebate. You can mail them in for a $2 rebate. So all 5 implies $2 rebate. Okay. So now you can think the process here is I'm going to buy a box of cereal. And each time I buy a box of cereal, I get 1 cartoon character. The problem is when I buy the second box of cereal, I might get the same cartoon character. So we might be interested in knowing what's the expected number of boxes of cereal I should buy, what's the waiting time in terms of boxes of cereal, okay, in order for me to collect all 5 cartoon characters. Okay. Now, turns out that I was a victim of this scam when I was a kid, about 9 years old. So, in my time, you had bubble gum packs. So bubble gum pack. And each bubble gum pack had a flag, one flag, okay, of approximately 169. So at that time, there were about 169 countries that had a population, greater than about 500,000. And so these countries qualified to have a flag, and so you buy a pack of bubble gum, you get a flag, okay? And it was this huge rage in school to collect all the flags, and there were these rare flags like Brunei and all kinds of unknown countries. Okay, that it was rumored that somebody had this flag, but then we didn't know anybody who had this flag. But you were still buying packets of gum until you get all the 169 flags. You get all the 169 flags. You become, the winner, the victor, okay? And so started a craze to buy bubblegum packs. And basically this meant that, I've got very strong jaws because I've chewed a lot of bubblegum in my youth, okay? So, each time you buy a pack, you're trying to get a flag. But the problem is that sometimes you might get the flag that you already have, so it doesn't add to your treasure chest. So you keep buying, okay, and you keep buying until you collect all the flags. So in terms of purchasers of bubblegum packs, I'm waiting to get all 169 flags, and we might ask the question, what is the expected waiting time until I get all 169 flags? Okay. Just like what is the expected waiting time in terms of boxes of cereal until I get all 5 cartoon characters. And so, in this case, you're clearly collecting coupons, the cartoons, and these coupons, the cartoon characters, and these coupons give you a rebate. Here, I'm also collecting coupons. The coupons are the flag, but when I collect all the 169 coupons, I don't get any money back, I just get fame. Okay. And so, this is called the coupon collecting problem. I call it the coupon collecting scam. Okay. Now, what's the expected wait? So let's look at what experiment is going on. We start and we buy bubblegum packs until we get the first flag. Okay, so first flag. Okay, and let's call the weight. Let's call the weight X1. The number of bubblegum packs I need to buy until I get the first. Let's say first new flag. The first flag that I don't already have. So let me call that the first flag that's new. Okay. Can anyone guess how long I have to wait to get the first flag that I don't already have? So I'll pause the video 1, 2, 3, 4, 5. If you're coming back and you said 1, man, at least you're following the discussion. Fantastic. Okay, yes, the first pack I buy is going to give me a flag. Okay. Just like the first cereal box you buy is going to give you a cartoon character. You didn't have that before, so it's new. Okay, but now it gets interesting. Okay, now I'm going to wait and buy bubblegum packs until I get my second flag. That's new. New means I don't already have it. And then I'm going to wait. So let's call the time I wait, let's call this time X2. And then I'm going to wait a time X3 to get my third flag. Okay, so that's again a new. When I say third flag, I mean third new flag. And I keep doing this until I get my last new flag, the 169th new flag. Okay. And the question is, okay, so let's say that I wait X 169. So the question is, what's the total time I wait? Well, the total time I wait, X, is same argument as we had before. It's X1, the time I wait for my first new flag, plus X2, the time I wait, the additional time I wait for my second new flag, plus X3, the additional time I wait for my third new flag, and so on. X169. Okay. And the theorem says that the expected value of this sum is the sum of the expected values. So the expected value of X is equal to the expected value of X1 plus the expected value of X2 plus the expected value of X3 plus plus the expected value of X169. Okay, but now we might think, well, the expected value of X1, well, X1 we know is 1. Okay, so the expected value of X1 is just 1. Okay, but let's try to analyze this more systematically. Okay, let's say that you are waiting for your kth new flag. Okay, so you are waiting for your kth new flag, waiting for your kth new flag. Okay, for your kth new flag. Okay, so the interesting thing here is you've gotten k minus 1 of the varieties. You have k minus 1 of the flags already. Okay. And so the interesting thing here is that the first flag, when you're waiting for the first flag, the probability of success, okay, with each pack you buy is basically 1. Okay, so the probability of success, P1 is equal to 1, which I'm going to choose to write as n over n. Okay. Now, let's see what's the probability of success for each of your trials when you're waiting for the second flag. So when you're waiting for the second flag, you've already gotten one flag, one variety. Okay, so there are n minus 1 varieties that you still need to get. Okay, but there are n varieties in total. So in this case, 169. Okay, so let us assume there are n coupons. In this case, varieties of flags, and in our example, n equals 169. Okay, so after you got your first flag, that kills one of the varieties. Now you have n minus 1 to go. Okay, so when you get your next pack of gum, okay, the chances are n minus 1 divided by n that you get a new one. Okay, the chances are 1 over n that you repeat the old one that you already have. So the probability of success for each trial when you're waiting for your second flag is n, so P2 is n minus 1 over n. That's the probability of success in each trial. And you will say that you succeeded when you get your second new flag. And so your probability of success is n minus 1 over n, because you already have one flag, and each pack of gum you buy, 1 over n of 1, there's a 1 in n chance that it's a repetition of your old flag. Okay? So your success chances are quite high, but not 1 anymore. You could repeat the old flag. Okay, what about your success chances when you're waiting for the third flag? Well, you already have 2 flags, so that leaves n minus 2 flags to be gotten. So your success chances, success chances, P3, when you're waiting for your third flag, is exactly n minus 2 over n. Okay, that's your success chance. Okay, and when you're waiting for your fourth flag, it's n minus 3 over n. And when you're waiting for your nth flag, the last flag, Pn, is equal to n minus of n minus 1 divided by n. Why n minus 1? Because you've gotten n minus 1 varieties. So every time you buy a new pack, okay, it's very likely, it's only a 1 in n chance that it's new. Okay, it's very likely that it's a repeat. Okay, and so sometimes we get this feeling that we're waiting for a long time for this last flag, and we think that they've conned us. They haven't put the last flag in any of the packets, because look, why would we have to wait so long? We only had to wait one step for the first flag, and we're going to wait so long for the last flag. Well, it's just a fact of the probabilistic analysis that you will inevitably wait a long time for the last flag, even though all flags could be equally, equally sort of distributed. Each flag is equally likely. Okay, so now we're ready to compute the expected value, because the expected, so now here you're waiting to a success where the success probability is 1. So this expected number of trials is 1 over P1. This is 1 over P1 plus 1 over P2. Now, so what's different here between the previous example of waiting to k successes? Here we're waiting for n successes, okay, where n is the number of varieties. And the success probability when you're waiting for your first success is different to the success probability when you're waiting for your second success. Okay, because the chances of your second success go down after you made your first success. And then here we have, the expected number of trials to my third success is 1 over the success probability for each of those trials. So it's 1 over P3 dot 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 1 over P n, which is 169 in this case. Okay, so this is equal to n over n, 1 over that, so n over n plus n over n minus 1, n over n minus 1 plus n over n minus 2, n over n minus 2. Okay. Plus n over n minus 3 plus dot 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 plus n over n minus 1. So I've just taken the reciprocals of all these guys and added. Why did I add? That's the expected value of a sum is a sum of expected values. Okay. Now let's massage this algebraically so we can do this quickly. This is n times 1 over n plus 1 over n minus 1 plus 1 over n minus 2 plus 1 over n minus 3 plus dot dot dot. And this is n times 1 over 1, which is just 1. Okay, so this is 1 plus, so this, this is the sum going backwards. Let's go forward and it'll become a lot more familiar. N times 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus dot 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 plus 1 over n. Okay, and this is n. This number here, the sum of the first n reciprocals, is called the nth harmonic number. So it's n h of n. We're done. Got a general formula. So the expected weight. Okay, so let's summarize this. The expected weight to collect n varieties of coupons is equal to n h of n, the nth harmonic number. The nth harmonic number, this is approximately equal to n log n plus, roughly speaking, there's plus n times a parameter that's called the Euler-Mascheroni constant, gamma, which is approximately 0.577, which is approximately equal to n log n plus 0.577 times n. That's your expected weight. Okay. Done. Okay, let's apply to these two examples. So first, the coupon collecting for the cartoon characters in the cereal boxes. So n equals 5. There are 5 characters of cartoons. Okay, so you need to buy 5 h of 5. Okay, which is approximately 12 cereal boxes. Okay, and if each cereal box costs about $5. So cereal box costs about $5, then you're going to spend $60 in order to get a $2 rebate. Whoopee! Approximately a 3% discount. Okay. What about my days as a young kid chewing bubble gum? Okay, bubble gum. Okay. Well, in this case, n is 169, and so n h of n is approximately equal to, and that's about 965. Okay, so let's say 970. 970 packs of bubble gum will have to be purchased by me. That's a lot of chewing. So let's face it, we were really buying the bubble gum to chew. This was just an excuse. The parents are shelling out the money. We are trading flags at school. It was a royal mess. Okay, but in order to collect all 169 flags, I would have to buy, approximately 1,000 packs of bubble gum. If I bought a bubble gum pack, if I bought one a day, that would be 3 years of buying bubblegum. You see why I call it a scam. The more varieties of coupon they put in whatever game they are playing, the more you will have to buy. And this guy, n log n is growing super linearly. Okay. So this log n factor, when n is, so you think, oh, maybe I only need to buy an order of n boxes. No, the log n factor comes in. Okay. The more varieties of coupons they have. Okay. So that's the coupon collector, and I call it the coupon collecting scam. Okay. So watch out for these things. Okay. All right. So, let's move on and talk about the expected value of a product. It's a little bit more complicated than the expected value of a sum. You can read more about it in the text. Okay. I'll just quickly, summarize.